Hi everyone, welcome to our next topic, which is all about multiple integrals. So this is our final topic for integral calculus after the applications for integral calculus. So let's proceed with the double integrals over general regions. So in this topic, we will learn how to use double integrals to find the areas of regions of different shapes. So for single integrals, the region over which we integrate is always an interval. So there is always an upper and lower limit for the single integrals that we already covered during the previous topics. So today, we are going to discuss about double integrals. So in double integrals, we want to be able to integrate a function f not just over rectangles, but also over regions D. So medyo ano siya, ang region, for example, kining si double integrals, regions murag ingon ani such as illustrated kining mura siya og wala siya proper bali na shape nga magamit nato ang katong singular or single integrals. Right? So kung sa single integrals, pwede ta mo gamit og trapezoid, rectangles as basis sa ato ang formula. For example, cylinder, circular, di ba? Magamit ta atong iyahang formula sa areas or volumes kung single na integrals or kung definite ang iyahang shape. Pero kung regions such as this one, we are going to use the double integrals. So we suppose that D is a bounded region which is covered by region R or enclosed by region R. So then we define a new function f with domain R by, so fxy is equal to fxy xy, f if xy is in D, inside the region D, or 0 if xy is in R but not in region D. Okay? So if f is integrable over R, then we define the double integral of f over D by the double integral of fxy dA is equal to double integral R capital F x y dA, where f is given by equation 1. So this one. So naatay condition. So f xy if xy is in D or nasa sulod ni D, and 0 if xy is in R but not in D. Okay? So that is our equation 1, and which is defined in definition 2. So double integrals. Definition 2, this one, makes sense because R is a rectangular, rectangle, and so the double integral of capital F x y dA from R is, so mao daw ni siya, no? Mao ni siya. Kung sa ato pa, kung makuha na to ni ang area bounded by region D, kung i-deduct nato siya sa area ni R nga wala kang D, no? So, medyo kung sa pinakadali lang, area R minus area D. Okay? So, the procedure that we have used is reasonable because the values of f, x, y are 0 when x, y lies outside D, and so they contribute nothing to the integral. This means that it doesn't matter what rectangle R we use as long as it contains D. So, wala siya nag-limit nga kung dadto ba, kung for example si R, diri kung pidpid ba kay siya or layo kay siya kang D, as long as na-enclose niya si D or region D. So in the case where f x y is greater than or equal to 0, we can still interpret the double integral of f x y dA as the volume of the solid that lies above region D and under the surface Z is equal to fxy graph of f. So for example, we can see that this is reasonable by comparing the graphs of f and small letter f and f, capital F. Here, remembering the double integrals, fxy dA is the volume under the graph of f. So, kung three-dimensional na ang ato ang region D. Okay, so we have y-axis, z-axis, and x-axis. So, naa siya dinhi. So, ang ato ang region or ang ato ang katong region R, which is a graph of f. So these figures also shows that f, capital F, is likely to have discontinuities at the boundary points of D. So nonetheless, if f is continuous on D and the boundary curve of D is well behaved, in a sense outside the scope of this topic, then it can be shown that the double integral of f xy dA exists, and so the double integral of f xy dA exists. So in particular, this is the case for the following type of regions. So there are actually type of regions wherein we can use these double integrals. So in particular, this is the case for the following type of regions. So type 1 regions. A plane region D is said to be of type 1 if it lies between the graphs of two continuous functions of x. That is, D is equal to xy if A is lesser than or equal to x, lesser than equal to B. G1 x is equal to y is lesser than or equal to y, lesser than or equal to G sub 2 x, where G sub 1 and G sub 2 are continuous on A to B. So for example, so here are some of the type 1 regions. Kini mura siya og kuano murag buhok ni Buttercup. D, this one, and this one. So these are types of some examples of type 1 regions. So we have y is equal to G sub 2 of x and y is equal to G sub 1 of x. So how are we going to evaluate the double integrals f of x sub y, x, y, dA when D is a region of type 1? So we choose a rectangle R. So this is the rectangle. So paano siyang kini? So R is equal to, so magkuha ta sa ato ang coordinates for our rectangle, no? R is equal to A, AB, AB times CD. That contains D. Okay? Naka-enclose si D bounded by AB. So this one and this one. Okay, so we have our length times width na nga form. Okay? So then we let f be the function given by equation 1. That is, f agrees with f on D and f is 0 outside D. Then by Fubini's theorem, the double integral of f x y dA is equal to katong gamit katong kaganina no nga equation is equal to the double integral of f x y dA bounded by the region R. And then hita mag-base kay region R. So we have the integral of double integral of f x y dy dx, which is our dA, from C to D to A to B. Sorry, nakamute. So observe that f x y is equal to 0 if y is lesser than g1 of x, or y is greater than g sub 2 x, because xy then lies outside D. So since ang atoang boundary is, or ang atong region is kini man si region D. Okay? Yan ha. Hello? Okay, so therefore, the integral of f xy dy from C to D is equal to the integral of f xy dy from g sub 1 x to g sub 2 x. So, because f of fxy is equal to the function xy when g sub 1 x g sub 1 x is lesser than or equal to y lesser than or equal to g sub 2 x. So naa natay boundary conditions. Thus, we have the following formula that enables us to evaluate the double integral as an iterated integral. Okay, sorry kayo. Medyo init kayo dahil sa balay. So if f is, for our equation 3, if f is continuous on a type 1 region D, so nakita naman nato kaganina ang mga type 1 regions, such that D is equal to xy, which is A is lesser than or equal to x, lesser than or equal to B, G sub 1 x is lesser than or equal to y, lesser than or equal to g sub 2x. Then our double integral of fxy dA is equal to the integral of the function xy dy dx. So dy dx is the modeling area, no? So from ang una na to nga integrate ani niya balik class is kini siya si g1 of x, g sub 1x to g sub 2x. Aya din nato ni apply ning integral of from a to b. Okay, from aya pa din si a to b. The integral on the right side of equation 3, so ang right side kini, is an iterated integral that is similar to the ones we considered sa katong previous natong topic. So the exception is that the inner integral, we regard x as being constant, not only. So karon naatay limits of integration na si g sub 1 x and g sub 2 x. Okay, so unsaon man ni siya og solve? Karon makita nato ni siya sa ato ang example, okay? So we also consider plane regions of type 2 which can be expressed as ano siya, d is equal, or di ba katong double integral d is equal to xy given that c is lesser than or equal to y, lesser than or equal to d, tapos ang ikaduha nga limit is h sub 1 y is lesser than or equal to x, lesser than or equal to h sub 2 y, where h sub 1 and h sub 2 are continuous. Okay, so dumdumon nato tong mga criteria, no, kung asa rata dapat continuous na siya, no. So two such regions are illustrated sa type 2 ni siya nga regions class, okay? So Ingon ani, bali murag sa to pa oriented siya vertically katong kagay na kay medyo horizontal man to no along ang ato ang boundaries kay naa sa y. So for type 2 regions ang atong boundaries kay x. Okay? So such as this one, kung kini ang ato ang region D, so we have x is equal to a sub 1 y, tapos ang ikaduha is x is equal to h sub 2 y. Kining isa ka type 2 region, x is equal to h sub 1 y, tapos ay ikaduha niya nga limit is x is equal to h sub 2 y. So kung magforma tag rectangle, ingon na ni ragyapon. Okay? Similar lang atong type 1 region. So using the same methods that we used in establishing the previous equation katong, nakakuha na taog limit niya no sa first na integral hangtod sa iyahang ikaduha or double integral, we show that the double integral of the function xy dA is equal to the integral of kung ang ato apong gipangita is naka-type 2 region is naka-integral of the function xy dx dy, which is the area, bounded by the limit h sub 1 y to h sub 2 y. Tapos, next dayon na integral na limit is from C to D. So, from C to D. Okay? Where D is a type 2 region. So, kung type 2. Kung type 1, so dapat kini siya G sub 1 times X, tapos G sub 2 is X. Tapos nauna si dy, ay din si dx. Okay? Balikan na to ha. Samantong kagay na si type 1. Tara, nauna si dy kung type 1 region. Kung type 2 region, una si dx, ay din si dy. Okay? Kita na to? So, for example, example number 1, evaluate the double integral of the quantity of the function x plus 2y dA, where D is the region bounded by the parabolas y is equal to 2x squared and y is equal to 1 plus x squared. So, given ani nga mga values, we are now going to graph no kung atong kung i-show nato kung unsa nga region yang gipangita. So the parabolas which is bounded by the which bounds the region D, first is when 2x squared, so kini y is equal to 2x squared, then the second parabola is 1 plus x squared. Okay? So when 2x squared is equal to 1 plus x squared, kung ato silang i-equate having the same value of y, so 2x squared is equal to 1 plus x squared, kung atong i-equate ni silang duha. So kung i-equate nato ni silang duha, so we have 2x squared is equal to 1 plus x squared. So we have ning si x squared atong i-transpose diri no. So 2x squared minus x squared will become 1. Okay? Or x squared is equal to 1. Okay? Thus, x is equal to positive or negative 1. So positive or negative 1. Okay, so we note that the region D is a type 1 region, but not a type 2 region. Okay? So, we can write D is equal to the, so atong igamiton tong state, ato ang equation kaganina, no? So, magkwanta, x, y, iyadang limit will be negative 1 lesser than or equal to x lesser than or equal to positive 1. Tapos, si 2x squared, which is the limit nimo sa imuhang lower limit nimo, 2x squared is lesser than or equal to y, which is lesser than or equal to 1 plus x squared. Kini, muha nga po limit. Okay? So, the lower boundary is 2x squared and your upper boundary is 1 plus x squared. So, mo ni ato ang kuha, no? Okay? So, the double integral of the function x plus 2y dA is equal to, so naa naman tayo, nakuha nga intervals, kagaya na, or limits. So, x plus 2y dA, so type 1 region man siya, so dy dx. Sorry sa header nga type 2 hat, na ato ni nga tronbe. So, type 1 ni siya. Dili na nakubutangan og label kay. Actually, example man ni siya good. Okay. So, balik ta. So, na naman ta dinhi. Mao naman ni atong mahimo og limits bali. Okay? So, natay upper and lower, no? Si 2x squared, ang lower boundary, tapos upper boundary is si 1 plus x squared. So, we write that as the integral of x plus 2y dy dx from 2x squared to 1 plus x squared, then from negative 1 to positive 1. Okay? So, nasa sulod si y nimo nga limit, no? Limit nato according sa y-axis. Tapos ikaduha na dayon si x kung type 1 nga region. So dili man mo maglibog ana kay ako pang giingon kagay na, no, mabala ninyo kung type 1 kay dy ni siya una. Si dy meaning kung kinsay una abay ani sa imong function mo na imong unahon og integrate. Okay? So therefore, we have, so holding the value of x as constant, so mahimo na siya og xy plus, kung integrate na nato siya ha, okay, so xy plus, mahimo man na siya og 2y squared over 2 using the power rule, no, of integration. Okay, so mahimo na siya og 2y squared over 2. Cancel na ang 2, so mabilin is si y squared. From y is equal to 2x squared to y is equal to 1 plus x squared dx. Therefore, ato sa ning i-apply kini siya nga integral na property. So we have x plus 1 plus x squared plus 1 plus x squared squared minus x times 2x squared minus 2x squared squared dx. So from negative 1 to 1. Then we simplify, tapos i-apply na sa day natong ikaduha nato nga integral na properties. Then the final answer is 32 over 15. Okay? So, dapat ani na gyapon ni siya nakabutang. Sorry class. Butang gyapon ta dire og 32 over 15 nga square units. Okay. So, note, when we set up a double integral, as in example, sa tong example 1, so it is essential to draw a diagram. So, oftentimes, it is helpful to draw a vertical arrow as shown. So, pariha ani, no? Makita na to, or we know that this region is a type 1 region. Then the limits of integration for the inner integral can be read from the diagram. So, since sa ato ang type 1 region, we use the lower boundary y is equal to g sub 1 x. So which is our lower limit, tapos atong upper limit is y is equal to g sub 2x, or a where it is a function of x. Okay, so for a type 2 region, the arrow is drawn horizontally from the left boundary to the right boundary. So opposite siya ato ang type 1 region, which is using or ang atong gipangita is ang iyahang dy una ay ata nag-apply kang dx. For the type 2 region, we are going to find the ato sa i-apply ang dx, no? Okay. So for example number 2, find the volume of the solid that lies under the paraboloid z is equal to x squared plus y squared and above the region D in the xy plane bounded by the line y is equal to 2x and the parabola which is y is equal to x squared. So now we are going to find the volume. So we have our solution 1. So naani siya another or alternative na solution. So kini solution 1 sa top. From the figure, we see that D is a type 1 region. So we have this limit, no? 0 is lesser than or equal to x lesser than or equal to 2, and x squared is lesser than or equal to y, which is lesser than or equal to 2x. So the volume under the paraboloid z is equal to x squared plus y squared, and the above region D is calculated as follows. So the volume is equal to double integral of our integrand, which is x squared plus y squared dA. So by applying the extracted na limits, so for our katong nasa sulod, okay? So ato ang since this is a type 1 region, we are still using the inner boundaries as dy. So the limit of y is x squared. The lower limit is x squared, the upper limit is 2x. So from x squared to 2x of our integrand x squared plus y squared dy dx. Ay din nato i-apply ni si integral of from 0 to 2, which is the limit of our x from 0 to 2. Okay? So, by integrating the kining nasa sulod, so una man nato nga integrate class is kini siya, no? Kining nasa sulod. So by integrating x squared plus y squared dy from x squared to 2x, applying the power rule of integration and letting x squared as a constant, so x squared y plus y squared or y squared plus 1 over 2 plus 1, which is y cubed over 3 from the limit x squared to 2x. By applying that and simplifying the equation, we have this equation, negative x to the power of 6 over 3 minus x to the 4th plus 14 x cubed over 3. Then we are going to apply the next na integration na. Okay, kana na dayon siya. Then from 0 to 2, so the final answer is 216 over 35 cubic units. So for the solution 2, so from this figure, we can also think na possible siya na mahimuog type 2 region. So when we solve this as a type 2 region, therefore we are going to change our integration or our limits, okay? So for xy, our limits will become, for x, it will become For the first na, no, katong sa iyang integration, no, from 0 to lesser than or equal to y lesser than or equal to 4. Okay? From 0 to 4. Kay limit na from from 0 to 4, while ang sa x nga limit is from, so gigamit nato ang katugyapong kaganina, rewriting it in the other na bali iyahang x na value. So ang ato ang given kagayna kay y is equal to x squared man. So now it becomes x is equal to y squared, okay? So gihimo ra ni siya kini siya gi-rewrite ra bali ni siya. So instead na y is equal to x squared, ang atong nakuha diri y is equal to x, sorry. May mo siya, sorry. Okay. So y is equal to square root of x square root of y. So dinhi, so in terms of x, we have 1/2 y. Okay? So I hope na wala mo na dili mo ma-confuse ana. So nanatay ang lahi nga limits, okay? So using type 2 regions meaning maguna si dx. Okay? Maguna si dx tapos si dy. Tapos ang imuhang limit dinhi sa unang pag-integrate mo is in terms of y. Okay. Dili ta malimot kani ato ang una i-integrate kini na sa sulod, applying the power rule and substituting the values of our upper and lower limit, then applying the second na pod nimo nga limit after nimo ma-simplify ang katong una, then imo ding i-apply ang ikaduha nga integration na property, then we can arrive with the same answer. Maski pa og type 1 or type 2 nga region imuhang gamiton. We have 216 over 35 cubic units. So let us proceed with double integrals. The figure shows the solid whose volume is calculated in example number 2. So, mao ni ato ang gisolve kaganina kini si paraboloid with z is equal to x squared plus y squared and above the region in the xy plane bounded by y is equal to 2x and y is equal to 2x and y is equal to x squared. Okay? So for example number 3, evaluate the double integral of xy dA, where d is the region bounded by the line y is equal to x minus 1 and the parabola y is equal to 2x plus x. So again, this region D, it can be both type 1 and type 2 regions. So maski pa og dili na mo mag-graph, no, pwede raman gyapon nga dili mo mag-graph, i-extract lang gyud ninyo ang given para dili mo maglibog. Okay? You can extract directly the given from the problem so that you can solve it continuously. Okay? However, the description of D as a type 1 region is more complicated because the lower boundary consists of two parts. So, kung magamit ta kung ang advantage lang kung mag-graph mo is makita ninyo kung asang mas complicated. No, kung magamit ta og type 1 region, mas complicated siya since you have an mura ka og makatunga ka og into two parts. Okay? So you have this boundary as y is equal to negative square root of 2x plus x and you have the positive square root of 2x plus x. Plus 6, sorry. Y is equal to negative square root of 2x plus 6 and positive square root of 2x plus 6. Okay? So, hence, we prefer to express D as a type 2 region for simpler solution. So, when we use the type 2 region, we have negative 2 is lesser than or equal to y, lesser than or equal to 4. Okay? Then, for our x limit, it's 1/2 y squared minus 3 and y plus 1. Okay? So, therefore, we can rewrite it using our general equation for solving surface areas, no? Katong surface regions. So, we have the double integral xy dA. So, similar ra sa itong gina-practice kagay na o ginasolve, ginagamit kagay na. Una na to og solve since type 2 region man ni, mag-una si dx. Okay. Kini using power rules, syempre ato dahil ipa-constant si y since nag-integrate man ta according ra kang x since dx man ni. Dili na to malimtan na si dx gani diri kay nagpakita ano action word na siya verb kung asa ra imong i-integrate, okay? Dili ta malimot ana. Copy? So, from the limit x is equal to 1/2 y squared minus 3 to y plus 1. Then, ayan din nato i-apply ang ikaduha nato nga integral. So, the final answer is 36. Sorry, wala siya nag-ano. So, the answer is 36 square units. So, let's proceed with the next. So, if we had expressed D as a type 1 region, we would have obtained a more complicated na function. And more complicated pod na iyahang limits. So, we can solve this one yapon and arrive the same answer, pero syempre mas complicated siya. It would take much of your time. Okay? So, for example, number 4, find the volume of the tetrahedron bounded by the planes x plus 2y plus z is equal to 2, where x is equal to 2y, x is equal to 0, and z is equal to 0. So in a question such as this one, it's wise to draw two diagrams. One of the three-dimensional solid, kung magamit mo og computer, so mas dali lang inyong pag-graph. So one of the plane region, and another is the plane region D over which it lies. So this figure shows the tetrahedron T bounded by the coordinate planes x is equal to 0, nadara, nadire, x equal to 0, z is equal to 0, nadire, yapon, and the vertical plane x is equal to 2y. And the plane x plus 2y plus z is equal to 2. So, morning nga plane. So, as the plane x plus 2y plus z is equal to 0 intersects the xy plane, whose equation is z is equal to 0, in the line x plus 2y is equal to 2, we see that T lies above the triangular region D in the xy plane. Within the lines x is equal to 2y, x equal to 2y, and x plus 2y is equal to 2. And x is equal to 0. So the plane x plus 2y plus z is equal to 2 can be written as, i-rewrite lang nato as z is equal to 2 negative x minus 2y. So the required volume lies under the graph of the function z is equal to 2 minus x minus 2y, and above the region D is equal to xy, whose limits is from 0 to 1 and from x sub 4x, and from x halves to 1 minus x halves of y. So therefore, we use the formula kaganina, the double integral of 2 minus x minus y dA is equal to the double integral of 2 minus x minus 2y dy dx from x halves to 1 minus x halves. Then for the second integral is from 0 to 1. Okay, so finally, the answer is 1/3 cubic units. Cubic units. So volume man ang gipangitaan ni no.